Hello everyone, today we'll be looking at the normal distribution and we're going to approach it by way of an example. So here it is. The length of a snowboard that a person would use is related to the height and weight of that person. The histogram below shows the heights of people that commonly rent snowboards at a ski shop. The first thing we need to do is draw a frequency polygon on the histogram below and describe the shape of the frequency polygon. So if we're going to draw a frequency polygon, we're going to need to draw little dots at the midpoint at the top of each of these bars and connect them with line segments. Once we've connected all the line segments, the frequency polygon will look like this, which looks a little bit like a bell. The bell shape for the frequency polygon indicates that this data is normally distributed, which means the heights of the snowboard renters in this shop follow a normal distribution. Now we're going to need to calculate the mean, median, mode, range, standard deviation, and the number of renters. We're going to do this with our calculator, and we're going to enter all the data shown in the histogram into our stat list. So we can go stat and choose edit. Now again, we can do this the easy way or the hard way. If we're going to do this the hard way, we would enter 61, 61, 61, 62, 62, 62, 62, and so on, and we'd have 1,000 numbers to enter into L1. So I don't know about you, but I would rather not enter 1,000 numbers into my stat list. So I'm going to just enter the categories into L1 and enter the frequencies into L2. So if you do it this way, it's really important for you to check that the rows match up at the end. If they do, you probably enter the data right. Maybe just take a second look that all your numbers are correctly entered, and now you can calculate your statistics. So we go stat, calc, one variable statistics. L1 is our list. We have a frequency list in L2, and calculate. So we can see our mean is 70.2, standard deviation is 2.984, there's 1,000 data points, the median is 70, and that's basically all we can get from the calculator for now. So let's record that data here. The mean was 70.02, the median was 70, and the mode we can get off the histogram by reading the tallest category, which is 70. The range goes from 61 to 79, so if we do 79 minus 61, the range is 18. The standard deviation we got from our calculator was 2.984, and the number of renters was 1,000. And now we're going to complete the following table and round all values to the nearest thousandth. The mean again was 70.02, I guess 0.020. The standard deviation was 2.984. If we take the mean and subtract the standard deviation, we get 67.036. If we start with the mean and add the standard deviation, we get 73.004. If we start with the mean and subtract two standard deviations, we get 64.052. If we add two standard deviations to the mean, we get 75.988. If we subtract 3 standard deviations from the mean, we get 61.067. And finally, if we add 3 standard deviations to the mean, we get 78.973. So next we need to determine the number of renters within one standard deviation of the mean. On the lower end, we have 67, and on the upper end, we have 73. So looking at our histogram, we're going from 67 to 73. Now for sure, we're going to include 116, 128, 147, 129, and 115. They are safely within the range. But what do we do about 67 and 73? Because potentially we might have some people just under 67. So what we're going to do with this one in particular, we're just going to sort of chop it down the middle and assume that this is evenly spread between numbers below 67 and numbers above 67. So we're going to take half of 64, which is 32, and we're going to assume the same thing for 73. We're going to assume that there are some below 73, like 72.8-ish, and some above 73, like 73.2 or 73.1. So we're going to cut this number in half as well. So the number of renters within one standard deviation is going to be given by this: 1/2 64 plus 116 plus 128 plus 147 plus 129 plus 115 plus 1/2 of 63, which gives us about 699. And because we're dealing with 1,000 people, if we divided this by 1,000, we would get 69.9%. Now we can do a similar thing with number 5. We're going to determine the percent of renters within 2 standard deviations of the mean. On the lower end, we're dealing with 64, and on the upper end, we're dealing with 75.9, so we could maybe call that 76. So here we're going to go 1/2 times 18 plus 30 plus 52, and so on, plus 53 plus 29 plus 1/2 of 20. Which is going to give us 945. And if we divide that by 1,000, we get approximately 94.5%. For number 6, our lower end is 61, and our upper end is 79. So what we could do is 1/2 times 3, plus 4, plus 10, and so on, plus 12, plus 5, plus 1/2 of 2. Which will give us 997.5. Alternatively, if we know we have 1,000 people total, we can subtract off the end bits. So we would subtract off 1/2 of 3, 1.5, and also subtract off 1/2 of 2, which is 1, and that would give us the same thing. So this works out to be 99.7%, or 99.8%. And now on to a few important characteristics of the normal distribution. All data that is normally distributed has the following characteristics. The mean, median, and mode are all the same. The graph of the distribution is shaped like a bell. The graph of the distribution is symmetrical about the mean. Approximately 68% of the data lies within 1 standard deviation of the mean, and approximately 95% of the data lies within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. This is what a normal distribution curve looks like. You'll obviously have a different mean than the one here, and the data may be more or less spread out than the curve here. In fact, I would encourage you to take this little widget for a spin. I made it just for you. You can kick the tires, maybe even look under the hood. You can move the mean to the right or to the left. You can change the standard deviation. The link for this is in the description. You should hopefully notice eventually that regardless of spread or horizontal position, these percentages remain the same. And that is one of the key characteristics of the normal distribution. So we can use the normal distribution curve to determine each of the following. What percentage of the data lies between x bar plus sigma and x bar plus 2 sigma? Well, x bar plus sigma is here, and x bar plus 2 sigma is here. So that would be 13.59, and that's true for all normal distribution curves. Next question, what percentage of the data lies between x bar minus sigma and x bar plus 2 sigma? So x bar minus sigma is here, and x bar plus 2 sigma is all the way over here. So we have to add up each of these areas. So 34 plus 34 plus 13.59 would give you 81.85. Next, what percent of the data lies between x bar minus 3 sigma and x bar? So x bar minus 3 sigma is here, and x bar is over here. So we have to add up each of these areas. 2.14 plus 13.59 plus 34.13. That gives us 49.86. And last, what percent of the data lies between x bar and x bar plus 2 sigma? X bar is here, x bar plus 2 sigma is here. We add this percentage and this percentage, which gives us 47.72. You may notice that if you add up all of these percentages, it doesn't quite add up to 100%, and that's because there's been some rounding here. And you can see these values a little bit more precisely in the Desmos demo. So here's some fun and easy questions for you to do. Number 8, we need to label the following normal distributions with a horizontal scale, given the mean and standard deviation. So these normal distributions aren't exactly drawn to scale. Their characteristics would change depending on what the standard deviation was doing. So my question for you is, which one of these would be taller? And if you don't know the answer to that, you should try the demo. So with this question, we start from the middle and work our way out. The middle needs to be 25. 25 plus 3 would be 28. 28 plus another 3 would be 31. And 31 plus 3 would be 34. And now subtract 3. 25 minus 3 gives 22. 22 minus 3 gives 19. and 19 minus 3 gives 16. And for this one, the mean is 60.3, and we add 1.5 to get here, so that would be 61.8, and we add another 1.5, which would be 63.3, and 64.8. And going the other direction, we subtract 1.5, which would be 58.8, and further 57.3, and furthermore 55.8. So I'll maybe leave this one for you to do as an exercise. And on to question number 9. Janine surveyed the battery life of her friends' iPhones and asked them to record how long the battery lasted before being charged with a lot of usage. Her friends came back the next day and gave her the following times in hours. So here's all our data. We need to figure out if the data approximates a normal distribution, and we're going to justify our answer by determining the mean and median of the data set. So calculator's ready, and we're going to enter these 30 numbers into our calculator by going Stat, Edit. So first we're going to start off with 10.5, 10.5, enter, then 7.7, enter, and so on. So now that we have all the data entered, we're going to go Stat, Calc, one variable statistics. So for this set of data, we're just going to go L1. We don't have any frequency list because we entered all the numbers individually. And then we're going to go down to Calculate. So we can see the mean is 7.86 and the median is 7.9. So the mean is 7.86 and the median is 7.9. So because these two are pretty close, that means we're approximately normal distribution. Our calculators also returned a standard deviation, which was 1.5149 and some other digits. So x bar plus or minus sigma, we start with 7.86 and we go plus or minus 1.5149. So 7.86 minus this number is 6.35, and 7.86 plus this number is 9.37. So now that we have a lower and upper limit, we can determine how many people have that range of battery life. So all of these numbers fit between 6.35 and 9.37. These numbers fit between 6.35 and 9.37. This one is outside. This one is outside as well. This one is close, but it is lower than 6.35. All of these fit. That one's out. All of these ones fit. These two are out, and these three are in. This one's a bit close, but again, it's outside of one standard deviation. So in total, we have 21 people with a phone battery that lasts between 6.35 and 9.37. So 21 out of 30 phones fit within one standard deviation of the mean, which is about 70%. We can do the same thing for x bar plus or minus 2 sigma. Again, we start with 7.86 and we add plus or minus 2 standard deviations. The lower limit on this is 4.84 and the upper limit on this is 10.88. So we can take a look at the number of people with phones that last between 4.84 hours and 10.88 hours. You can see it's every phone in the data set except for this one, so 29 out of 30 phones. And 29 out of 30 gives us about 97%. And finally, we can do x bar plus or minus 3 sigma. Our lower limit is 3.33, and our upper limit is 12.39. Now all the phones that we've sampled fit in this range, so 30 out of 30, that makes 100%. Next, we're going to complete a frequency table and draw a histogram. So we're going to work from left to right, starting with x bar minus 3 sigma, then x bar minus 2 sigma, x bar minus sigma, x bar plus sigma, x bar plus 2 sigma, and x bar plus 3 sigma. The intervals are from 3.5 to 5, 5 to 6.5, 6.5 to 8, 8 to 9.5, 9.5 to 11, and 11 to 12.5. We can mark off the phones that we see in each interval. In this interval there's 1. In this interval there's 4. In this one there's 13. In this one there's 7. In this one there's 4. And in this one there's 1. So the frequency we can record 1, 4, 13, 7, 4, and 1. And if we were to draw a histogram with this data, here's what it would look like. Hours along the bottom, frequency vertical, have a title, no spaces between the bars, and that's it. Moving on to question number 10. The number of years of teaching experience for the staff members at a high school in the south end of the city is normally distributed with a mean of 15.5 years and a standard deviation of 4.5 years. First thing we need to do is sketch a normal distribution curve and label the horizontal axis appropriately. So we'll draw some separators. Our mean is 15.5. One standard deviation above that is 20. 2 standard deviations above the mean is 24.5. And 3 standard deviations above the mean is 29. In the other direction, we have 11, 6.5, and 2. And the percentages for each of these segments, 34.13% here, 34.13% here, 13.59% there, 2.14% here, and 0.14% here. And it's basically the same in the other direction. And we can label the mean with a mu. So in part B, if there's 85 staff members, how many teachers with between 11 and 20 years of teaching experience? So between 11 and 20 accounts for 34.13 plus another 34.13. So 2 times 34.13 is 68.26%. And if we want to figure out how many teachers that represents, we multiply 85 by the percentage as a decimal, which is 0.6826. And that works out to be about 58 teachers. Next, we're looking at how many have less than 2 years of teaching experience. Looking at our diagram, less than 2 years here, 0.14% have less than 2 years. So now we need to figure out 0.14% of 85. So 0.14% as a decimal, we need to divide that by 100. So we get 0.0014. That's the number we need to multiply by 85. And that gives us a number of 0.119. So that's basically no teachers. Next, we're looking to find out how many have more than 20 years of teaching experience at the school. So looking at our distribution, 20 is here, 13.59 plus 2.14 plus another 0.14. So that plus that plus that. So 13.59 plus 2.14 plus 0.14. We get a total of 15.87%. And if we want to figure out how many teachers that amounts to, we go 85 times that number as a decimal, which is 0.1587. And that gives us 13.49. So approximately 13 or 14 teachers. I'm going to leave this question for you to do. The results of the first round of the 2009 Masters Golf Tournament are given below. Here they are. You can enter this data into your calculator the easy way or the hard way. If you do it the hard way, you're going to have to enter 96 numbers into your calculator in L1. If you do it the easy way, which was shown earlier in this video, it'll be much quicker. So what I need from you is a photo of your calculator with the first 7 rows of L1 and L2 filled, or L1 if you prefer the hard way, and a photo of your results of the one variable statistic calculation from X bar to N. So I will tell you that the golf scores are pretty much normally distributed in this question. And for proof, if you need a hint. So that's it for me for today. You can try these questions out if you like as well, and I'll see you next time.